So what I'm going to do today is give you a brief ecological history of our area here in southwestern Oregon. I've titled my presentation Past, Present, and Future of Oregon's Forest. We'll talk about the past and the present, and maybe we'll have a chance to talk about the future when it comes time to do a breakout session. So first of all, three big questions here. Where did we come from? Where are we now? And where do we want to go? And as I say, we're going to concentrate on those first two questions, and then maybe we'll have some time for discussion in the last one. So I'm going to present to you 50 years of landscape history using a variety of ecological, historical, and archaeological data, and then bring us up to the current conditions. And then I always like to think about where do we want to go as fate sheds. We talk about air sheds and view sheds and watersheds, but we have foreclosed certain options going into the future, and so our fate shed is limited just like a watershed. So that's a way I kind of think about looking at the future. So first of all, what can we measure? Two important things that historical ecologists think about is what we call the historic range of variability. So when people talk about restoring an ecosystem, oftentimes they make the mistake of saying, okay, we're going to restore it to some condition, some pre-European condition, and they pick a number like 1825 or something. Whereas ecologists, historical ecologists, understand that the variability within landscape covers a range, right? And so it might move toward one extreme and toward another extreme, but it wanders back and forth between two sets of borders. And so looking at the historical range of variability gives us an idea of what to manage to. So if we manage toward the middle, when crazy things happen like Archie Creek fires, we still have room to go till we hit the extreme. That's unfortunately not the case anymore, and I'll be showing you data on that. And then the second are ecosystem reference conditions. Okay, what historic range of variability of what? And so what is it that we're going to be measuring here? And it's these ecosystem reference conditions that I'll be talking about here. So we can look at those conditions from, the stand level, sort of standing in the forest and looking around, touching things and that sort of thing. At the landscape level, we need to be up at high elevation. Usually we're talking satellite imagery or at least high altitude reconnaissance aircraft and so on. So from a landscape level, we tend to look at the landscape in a broader sense. We look at, and these are technical terms, patch, corridor, and matrix. This is what landscape ecologists use to talk about how the landscape is configured. So the matrix would be most of what's going on out there. And so historically, this would have been largely forested, but with patches of meadows and shrublands and corridors of ridge tops and creeks connecting them. We can talk about habitat proportions. How much was old growth? How much was brushland? How much was meadow, right? We can talk about the tree species proportions and distribution. Were there more fire tolerant species? Were there more fire intolerant species? And how did those range over time? And then we can look at disturbance patterns. And of course, we're going to be talking about fire, which has been largely supplanted by logging, but in the last few years, fire now is a dramatic disturbance factor on the landscape. At the stand level, we can look at tree species demographics. How old are they? What's the range of ages of those trees out there? What are the different ranges of the different types of species? We look at stand architecture. Do the trees have big branches, which indicates they're open grown, they've had lots of sunlight during their development, or are they tall and narrow timber trees which have been grown in a more crowded condition? And then of course we can look at the stand level disturbance history too, how much fire and or logging has gone on. So what pieces of evidence can we use? How do we put this puzzle together? And so this is a graphic that I created to talk about all the different kinds of data that one can use to reconstruct historic landscapes. So starting, with history, we have great explorers journals, we have oral histories from tribal members, material cultures as we head toward archaeology. What do we dig up in archaeological sites? What were people using in the landscape? Paleoecology, we can look at pollen diagrams in the bottoms of ponds to see how vegetation has shifted over time. Dendrochronology, dendro from tree, chronology from time. These are tree ring studies. What can we learn from tree rings when we look at the cross section of those trees? Remote sensing data from satellites and other imagery. Vegetation inventories that were taken on the ground over the years. We have many data sets of those over time from an ecological perspective. Historic photos have been really invaluable. Old maps and documents, landscape art, which I will show you some of, and toponymy, a great word. Topo, from landscape, from topography, and nymi from name, place names. Peter Paul Prairie is mostly not a prairie anymore. Burnt Mountain is no longer a burnt mountain, right? And so we can get a sense of what the landscape was like by what the early explorers called them, right? And so the area that I concentrated on in my research on the use of landscape fire by the native peoples in this area was the Little River watershed. But what I discovered is fairly applicable to southwestern Oregon and parts of northern California. So looking at old maps, this is a map of the route of the Emmons Party right through the Umpqua in 1841. You see the dotted line, the trail that they took down as they explored down into California. And so we have some great records of that expedition, pencil sketches that were made by Henry Eld at the end of every day's march. This is, right now, I-5 would run right along here, okay? So this is probably just a little bit north of Canyonville in that area that kind of follows that hill mass around the South Umpqua River there. But what's interesting about this drawing is, first of all, just when you look at it, you say, wow, where are all the trees? And so this was down in the valley, and this landscape was burned on a yearly basis. And right in the sketch, if you look in the background, this is September 21st, right? This is in the fall when the Indians would typically burn large proportions of the landscape. And so you see that pall of smoke rising in the background. That's not a campfire, right? That's way too big to be a campfire. They're burning the meadows there. And so if you look in the middle ground, you see these orchard of oak trees. Several historical accounts of pioneers coming over the Cascades and into these valleys talked about the orchards of oak trees, these widely spaced, almost manicured oak trees. And acorns were an important source of food, especially for the California Indians and some of the other tribes. I talked to a Cow Creek elder about acorns because we don't have any bedrock mortars. In California, you find areas of bedrock with holes worn into them from people grinding acorns in them for thousands of years. We don't have those on the Umpqua, and so I asked Chuck Jackson, who is a tribal elder that passed away a few years ago, and he said, well, acorns take a lot of work to prepare. They don't taste very good, and so, but we managed the oaks so that the deer would eat the acorns, and we ate the deer, and that was a better way to process the acorns. So everybody had their own, each tribe, excuse me, had their own traditions about how they managed their land and what they needed from their land. And so how do we know how often they burned? There are pioneer accounts that talked about them burning every year. This is from a stump of an oak tree that grew right just close to where I'm sitting right here, just upriver from Umpqua Community College, excuse me. And so you can see that this tree, when it was young, it germinated around 1795, and there was a fire scar in 1805, 1808, 1811, 1813, 1815, 1818. So, and then it appears that the fire stopped here, right? But there was another stump that I found nearby that germinated 50 years earlier, and it had a similar pattern in its first 20 or 30 years. And it was growing 100 feet away from this oak tree here. And all of those fires in the early 1800s did not show up in this other tree that was right nearby, because once the tree gets big enough and the bark gets thick enough, it no longer scars. So, so these young trees would pick up the scars and survive, and they record that fire history in those tree rings. And so you can see how badly burned this thing was when it was young. It was almost killed, you know, over half of the cambium was destroyed, but it kept surviving, kept surviving, kept surviving. And then finally it got big enough and healed up enough to continue on until, unfortunately, it was cut by my neighbor to clear pasture for sheep back around 20 years ago. So there's a tree ring history, that dendrochronology that I talked about, pyrodendrochronology, if you're actually looking for fire scars in it. We talked about architecture of the stand, right? And we see this old snag in a stand of younger timber, but look at all those branches down here, right? Well, why don't these trees growing on the same site have those branches? Because this tree was an open grown tree that was maintained by underburning those forests and keeping them widely spaced. And then as this young forest came in, Indians were removed from the landscape, fire was removed from the landscape, and therefore, you know, this tree got crowded and choked out. But you can see by its architecture that it was an open grown tree. Here we have an Oregon white oak up near Illahee Flats, same story, young conifers in here in the absence of fire. So fire maintained, these are fire adapted landscapes with a fire adapted keystone species on the landscape. You've probably heard this term in ecology. A keystone species is an organism that has an inordinate effect on the diversity of the rest of the system. So think about beavers, right? Beavers are a keystone species because they make dams, which holds the water, which creates habitat for other organisms that live behind those dams, and it also slows the water down and keeps those streams from scouring, right? Well, Indians were keystone species on the landscape because they controlled the fire regimes. And with their absence, we will see a big shift in ecosystem structure. We have maps, old aerial photographs, and now satellite photos. And for reasons that I don't have time to go into, most of you know that we live in the BLM checkerboard. Every other square mile is public and private land. And so the lines have been drawn here, but the red area is cropland, the yellow area is pasture land, and the green area is woodland. And you see that a lot of that area got encroached in the 50, 60 years since this map was drawn. But then by the time the 1990s roll around, almost all of that older forest is gone and just left into little remnants. So remember I was talking about corridor, patch, and matrix? Well, back in the old days, this was the matrix and these were the patches, right? And now it's the young plantations that are the matrix and the old growth stands are the patches. Same kind of story here. You can see this was important because they were mapping spotted owl habitat, and the spotted owls need interior habitat, and they were using those old aerial photographs to extrapolate backward in time. And you can see that paradoxically, by the mid part of the last century, there was more interior habitat for owls than there was historically. But now, by 1992, that interior habitat was almost gone. And then you can see the older forest here, the dark green, the younger forest in light blue, and the very young forest in yellow. And you can see that there was quite a mosaic of that in historic times. That closed in pretty significantly after Indians were removed from the landscape. Landscape fires were removed from the landscape. And so the forests grew back in, but now by 1992, we see that's been pretty seriously degraded. And now we see the lines, the cadastral lines from the BLM lands. You know, you can see those now from space because cutting tends to be, you know, the ownerships are along those straight lines, and so the cutting follows those straight lines. Here's another sketch by Henry Eld, when they're crossing the Umpqua Mountains. This is facing north, so it's late in the day with the light shining on the sides of the trees here. And so you can see this western facing slope has individual trees drawn on it. He hasn't drawn this really heavy timber, right? And so that suggests that probably somewhere down here was a management area where they ran fire up into the hills and created these savannas, lots of downwood, lots of open areas embedded in this matrix of timber there. These could be fire lanes in here where fire crowned and took those trees out. They could be you know, meadows, rocky areas. We just don't know. It's very tantalizing to try and figure out what it was he was drawing. But this is a typical, very variable landscape. We can use archaeology. We know where they were by the things that they left behind. Here's a rock cairn, a Vision Quest site. Right behind that is Quartz Mountain, which was a sacred mountain for them. And so this was a prayer seat or a vision mound. And these rocks, you can tell they're old because the lichens are all encrusted in the rock. So that rock was placed far before Europeans arrived in the area. This is Dog Creek Cave with the little finger painted Indian with his bow and arrow. This is a medicine tree, or the snag of a medicine tree, and you can tell a medicine scar from a fire scar because the fire scar starts at the base and is kind of parabolic shaped. This is squared across at the bottom. Why did they do that? Because the inner bark of pines is very rich in vitamin C and other minerals. And so late in the year, when when it may have still been snowing and all they have is meat and various other dried protein to eat, they needed those veggies, and so they would peel these trees probably as a hedge against scurvy. So placing all of these together, we're able to place these sites on the landscape. Now, what's this spaghetti all about? What I did was I took 10 well-developed sites or well excavated and described sites, and then I created a set of mapping rules to say, okay, where would the Indians have been going? How would they have gotten from one site to the other? So the way I did that was I created mapping rules and sent the computer across the landscape in the easiest way possible. And then I tweaked my model until it picked up all the sites. So you see, it's running, these paths are picking up all of these sites, right? But I didn't send them to those sites. So that's how I validated the model. So it turns out that if you look at the evidence associated with archaeological sites and the least cost pathways that connect them, the old road system, you find evidence of frequent fire associated with those areas compared to areas that are not near archaeological sites or not near the pathways that connect them. This is interesting here. This is out of that Clover site here, which I showed you on the last slide, but I didn't talk about. Anyway, there's up where they were traveling, they were burning out the meadows because it made good sense, right? You don't travel along the creeks unless you're a European and you've got a bunch of animals that you need to have near the water, right? They traveled up on the ridges because they could keep them open with fire. They could observe things, and that's where all their camps were. So anywhere where there was a spring and a meadow, they burned it out because they wanted the table to be set when they arrived. They didn't want to carry their food over the mountains to trade for obsidian or communicate or party with the Klamath over on the other side of the mountains. But they traveled on the ridges, and they made sure that these yards were burned out so that their food would be available when they arrived. And you can see up on the ridges, it looks like, oh, there must have been, typically forest ecologists will explain something like this, where these are tree germinations. When did the trees germinate, right? How old were they? And you see no trees here. And so people say, oh, there must have been a catastrophic fire there that burned down every tree. But I think more likely than that is that when the Indians were run out of this area and sent to reservations and died in huge numbers from epidemics, they stopped burning. And so these trees came back. That's a more plausible explanation for this graph. Now, just down the draw, in the steep ground where I hypothesized they weren't managing as much, you see this tree germinates in 1450, and then in the 1500s there's a couple, in the 1600s there's a few. Fire, fire, fire all the way through. So there's tree germinations and fire happening all the time, because those systems were very chaotic systems where these forests would experience fire after fire after fire, but the big old trees would survive. Okay, and then here you just see all these trees sprouting up suddenly right about the time that Indians disappear from the landscape. And then here we are up on the ridge. Henry Eld makes another great sketch, and look at that. Right up on the ridge, those trees are burned out, right? And so that's where they were traveling. Why were the Europeans up on the ridge? Because the Indians had already cleared the road, and that was the best way to get over the mountains. Here's another fire here, probably too big to be a campfire. They were probably burning out around a campsite before they headed back down into the valleys for the winter. Our Indians were seasonally migratory. They lived in areas like this around UCC. There's a major village site just downstream from Umpqua Community College, Deer Creek, Cow Creek. Those were areas that they could get down to lower elevations and not get as much snow and cold weather as up in the mountains. So they would move up into the mountains every summer and back down every winter and burn their areas out as they left. You can see that here, Watson Watson Falls and Watson Butte, talking about the Indians burning off the land each year. Doing this every year made it so the fires were light and that there was no damage to the big timber. So here's an example of, we have archaeological evidence, we have ecological evidence, and now we have historical evidence that all triangulate in on the same story, that the Indians were managing this area with fire on a regular basis. Here, Eld, the same guy who was doing the pencil sketches, talks about, as they're on their way into the Siskiyous up and over the pass, they came across an Indian woman who was blowing on a brand to set fire to the woods, probably. We stopped to speak to her, but she was sullen and dogged and probably completely intimidated by all these white guys on horses. But we found the woods in fire in several places, and at time had some difficulty in passing some of the gullies where it was burning. Nowadays, they have some difficulty saving their lives, getting the hell out of there, because we have so much more fuel in the fire in the forest now, because the forests have become, have stopped being underburned by the Indians. So what do tree rings tell us? Bunch of scary data, but here's the takeaway. Before Europeans arrived, there is no correlation between weather and fire, no correlation between rainfall and fire, rainfall and tree germinations, or fire and trees germinating the year after. But after Europeans take over, the climate is now driving fire and germinations. So Indians were controlling the fire regimes to meet their agroecological objectives. If it was a rainy year, they were going to wait till a couple of dry days to burn that huckleberry patch, because it needed to be burned if the people were going to eat in 2 years, right? Which is how long it would take the huckleberries to recover. So fire suppression comes to the Umpqua and things really change. Here's a data set that I found in a file cabinet at the Forest Service, and look at the amount of fires don't change, right? The number of fires don't change, but look at the acres, total acres burned, and the acres per fire. Look at this, 600-700 acres per fire. Okay, that's like nothing. Lots of small fires, but then fire suppression. They took some time off. They kind of dropped the ball during the Depression, but minimal fire suppression, the gap in the Great Depression, and then industrial fire suppression. But look at this, the greatest amount of total areas burned was 40,000. The Archie Creek fire alone was over 3 times that. So we've got big changes and big consequences for those changes. Studies have shown that old growth developed at very low densities because the Indians were, none of these scientists, unfortunately, closed the loop that a lot of the reason these were open is because of Indian burning. but that's the best explanation for why forests developed at low densities in the past, but are developed at very high densities now. So where are we now? Looking at trends in forest conditions, multi-cohort stands, that is multiple different ages, have given way to even age stands. Average age and diameter of trees have decreased. There's an increase in stand density, a decrease in large trees at the stand and landscape level, decrease in structural and biotic diversity because of that. At the spatial and temporal shifts in fire patterns from many small 600-acre fires, but lots of them, to few large fires, frequent to infrequent, and low intensity fires that didn't even kill the trees and left fire scars in them, to high intensity now that just obliterates the standing timber. And then changes in forest management, corridor and yard openings to disperse clear cuts, ridge and rivers that the Indians concentrated onto the whole landscape, extensive, where Indians were burning lots of the landscape, but very lightly, to intensive, where small parts of the landscape are treated, but clear cut. And then major disturbance agents has gone from fire to logging, although we're seeing the shift back to fire now. And systematic ignition has given way to systematic suppression. Okay, so just quickly in the last couple of minutes here, how are these changes working out? Just to take the Douglas Complex fire, this is a fire spout or a fire NATO that formed when an even age stand burned. It creates its own fire weather. That was 49,000 acres. We used to think those were big fires. And this is the map of it. And here you can see this was a plantation that completely burned. Whereas these old growth stands, they got cooked around the edges where the fire ran across these plantations, but left the interiors green. And then you can look to see where the plantations were and where the highest heat came off from the satellite images. Okay, and more of the same here. And then I was all set to do an analysis of the Douglas Complex fire to quantify that. And then fortunately for me, Zalden Dunn did that study, and they found that intensive plantation forestry characterized by young forests and spatially homogeneous fuels, where all the crowns are touching each other, rather than pre-fire biomass, were significant drivers of wildfire severity. So it's not the amount of fuel, because old growth forests, clearly have lots more wood in them than plantations. It's the structure of the fuel that drives fire severity. And then just lastly here, an analysis that was done recently showed that there are several experimental forests that Tim Perry and Julia Jones looked at, and they discovered that in areas where there were paired watershed studies, where they would clear cut one watershed and leave the other one intact, that even after 60 years, the conversion of old growth forest to Douglas fir plantations had a major effect on summer stream flows. Even 60 years later, the stream flows in the clear cut in the plantations versus the primary forest were 50% lower. So our forest management has created more flammable forest, more fire-prone forests, and less water in the streams to moisten that area. So drought conditions, warming, global warming is upon us. We got Santa Ana type winds for the first time, which drove the Archie Creek fire and all these other terrible fires. That's new. So we're entering a new phase of how to deal with our landscape, because we've restructured the forest to make them more fire prone, and we have less water in the streams because, for reasons we can talk about later, those young stands are pumping water out of the soil and into the atmosphere, so stream flows have gone down. So where do we want to go? That's the teaser here for our discussion section, so we can discuss that during our breakout session if you like. Okay, and I will stop sharing.